All right, let's take a look at a subject that I'm sure most of us can relate with, but maybe from a perspective that you haven't thought about before. So, this article here is about the urge to pee, when you have to really pee badly, and how does that affect your brain, basically, like your decision making, how good of decisions you make when you really have to pee badly. It's a pretty interesting study. Let me just hit some highlights here. So this shows basically what happened is they got a bunch of participants in here. The participants initially just peed, so they were emptied their bladder, and then they drank a lot of water over time, and they rated the how badly they had to go pee over time, and then how much pain they were actually in. So this is how badly they had to pee, and the bottom one here is the pain. The word void means when they actually peed. So they were taking these little cognitive tests along the way, the tests to measure their brain function, their decision making along the way. And then this is right before they actually peed, when they had to really go. And this is after they peed. So this is just telling kind of over time, as they drank more and more water, they kind of had to slowly go more and more badly to the bathroom. So let's take a look at how it impacted their performance on these tests. Um, and you can see here that they were given 5 different tests, one at the very beginning, and just a little bit, they had to pee a little bit, pretty strong, and extreme. This is where like they were probably just cranking out this test right before they were actually going to the bathroom, and then after they had gone to the bathroom. And if you look at, without getting into too many details, look at what happened here. Let's look at these assessments. So they're looking at the speed, so how quickly they were able to perform the task. So a lower number here would be better, and make that a little bigger there. And you can see that initially it was the average speed was 2.4. It stayed that way up until the extreme urge to pee, and then they got a little slower at performing these cognitive assessments. And then it returned to their roughly their normal level. Same thing with a couple other type of tasks, identification and working memory. Um, Speed kind of stayed about the same until they had that extreme urge to pee, and it went up and then down. Same thing for working memory. Now you'll notice these 2 little letters, they're pretty important. If we scroll down, they actually give us a p-value. So I didn't think about the term p-value here. What this is saying is the null hypothesis would be that the level of urgency with which you have to go to the bathroom does not impact your performance on the test. That would be the null hypothesis. The lower the p-value is, the more evidence we have against that null hypothesis. Very specifically, let me give you the definition. This is one of the questions on the quiz this week. What does this p-value mean? It means if the urge to go to the bathroom really has no impact and no connection with your performance on this identification task, then the chance of getting these slower times, slightly slower times like we did in our sample, uh, would only happen 2.7% of the time, 0.027. Yeah, 2.7% of the time if we change this to a percent. So if, you got to have that null hypothesis in there, if the null hypothesis is true, if the urge to urinate does not impact this at all, then we would only see results where it went up this much above these other times. We'd only see those kind of results 2.7% of the time. Results like this, or even more extreme, where like the time went up even further. So it doesn't look like it's due to randomness. This is a pretty low p-value. It's certainly below the 0.05 that's the typical cutoff. So this tells us statistical significance. In other words, it looks like that extreme urge to pee does have some kind of connection with how fast we perform these tasks, or the student subjects in here. And it's low enough that it's not just the subjects in the, I mean, the subjects in this test clearly were slower when they had to pee. But the point of inferential statistics here is it's enough slower than these other times that by saying it's statistically significant, we're saying that these results could be generalized to a larger population also. It's not just for these specific. If this p-value was higher, we'd say, okay, yeah, it was slower for these particular people, but we can't really generalize that beyond these particular test subjects, participants. And same thing here. We also have a p-value below 0.05. So we have statistical significance, but that's not the end. By the way, I really like that they gave the specific numbers here. They didn't just say p less than 0.05 or p greater than 0.05 like they did here. I think it's best practice to give the actual p-values. If it's less than a certain amount, because it might be 0.00005, this is okay. But here, I want to know how much above 0.05 it is, because a 0.052 is very different than a 0.67 or something. The lower the p-value, the more evidence there is against the null. So you want to know how much evidence there was against the null. It's always good practice. This is another question on your quizzes. It's always good practice to put the exact number of the p-value, unless it's really small and you're just saying it's below that cutoff that's much below our alpha level. So that's statistical significance. But does it matter? I mean, how big of an issue is it that their reaction speed was 6/100ths slower than when they didn't have to pee? Does this really matter, and is that a significant impact? That's what practical significance is. So we dip down here. They do a nice job of addressing this. So what they did is they calculated something like a Cohen's d that you'll be calculating this week. In other words, how many standard deviations of a difference. It was a Dunlap's d, but pretty similar idea. And they compared it to two situations that I think we do take very seriously. Blood alcohol level and fatigue associated with 24 hours of staying awake. And you can see here that in this task right here, the identification task, that extreme urge to pee slowed the reaction time down about the same amount as 0.05% blood alcohol, and just a bit less than 24 hours of not having any sleep. And on this other particular test, it turned out to be that the extreme urge to urinate really slowed down the task, even much more than they've done this task in other studies with people who had high blood alcohol levels and who had stayed up for 24 hours. So why does this matter? To me, this matters when you're driving a car. I'm not sure about you. I've certainly been in situations where I really had to go to the bathroom and some rest areas were closed or something, so I just kept driving. That at some point becomes basically the same reaction speed as being drunk, or as being really tired for driving. And so that's good to know. It's good to know in yourself if you're driving people. Maybe this study is good justification for stopping and finding a jug or finding someplace beside of the road. This is going way off topic of what I plan to. But the point is here, there is some practical significance here. So not just statistical significance, but it appears that the effect itself is pretty large and is meaningful in certain contexts.